So I'm David Ravi. So today I'm going to talk about this model verification director updates on 2022. Okay. So today I have this agenda, a few updates on the GUI side and connection performance, Spotweld and comparison other checks. Okay. As usually, I start with my overview of the functions available in model verification. We do have 7 functions in model verification. Now all these functions can be accessed through HyperWorks. And day by day, each of this function is contributing to the customer performance. I put a graph on the bottom right side. Um, People from automotive, heavy industries, aerospace, and electric and electronic industries are our main customer. I could see people reporting that they are able to save time and they are able to achieve efficiency by adopting our new versions. So today we are going to talk about this version 2022. For a long time, I kept the GUI, old GUI, as a classic, which was developed based on the TK. So now we completely moved this new, the old GUI with the new interface, same as HyperWorks look and feel. Okay. We have migrated all our MVD related GUIs to this new interface, and we use the Qt program for that. Now, while redesigning this GUI, we also implemented tooltips, images, and some places we are also planning to add videos for each and every parameters and each and every settings. Okay, so the GUI itself will help you as a tutorials for you to use or for your customer to use. Okay, and I'm very happy to say that in the past there were so many interface in MVD. We were all managing this in TK or HW2022.0, and this GUI has a specialty where we used to run multi-process, and each process communicates to the front ground GUI by a thread, and intra-process communication happens. And this GUI is very important for us. So that's the reason it took a little bit time. But when we started migrating the GUI, it took very easy for us because everything is managed in a XML. In a single XML, the whole MVD GUI was able to uh, develop and manage. So with a single XML file, the whole GUI can be driven. This is a good point. We can also communicate this to customer. This is a unique function in HyperWorks where it's built on completely a customization solution. But now even the look and feel looks like HyperWorks standard function, and we follow the same standards. And the migration process is very easy and it is easy to maintain. Regarding the progress and status bar, it was integrated into GUI in the past, but now we detach those progress messages, and now it's a part of HyperWorks session itself. On the left down session area, you can see the progress message when we execute any functions in MVD. The help button was there in the GUI, and user is to press that help to check the help online help. Now it is removed, and we follow the same strategy as HyperWorks. Okay, so while using any of this interface, if we press on F1 button, then online help will be displayed. So few recordings on this GUI. This is the new HyperWorks session 2022. Um, as soon as you click on the verification and right click on intersection, the workflow, we have kept the same thing when compared to the previous. Only the GUI is modified. The workflow still remains same. In addition to the workflow, we also added this tooltips and other functions. Okay, each and every function looks similar. So if you learn or master one interface, then rest of the function is easy to use. There are multiple checks and some other additional functions which we kept collapse and expand functions so that you can minimize or keep it compact when you're using it on HyperWorks. On the comparison side, similar way, and you can move the GUI to left or right by using this header option. And while running the function, you can minimize the GUI so that it can be very compact. So while running any function on the left down side, you can see the status message and progress bar. Okay, so now it is a part of HyperWorks itself. So the next one is connection check. The connection check is the bolt hole or bolt nut mismatch checks, and it is built for checking all the bolts and nuts, all the connections like continuous welds, so on. So, okay. So it is widely used in automotive places. The main function for this one is the holes. Okay, the hole detection was taking too much time, and it has a lot of performance issues in the past. So we have cleaned up and improved some additional logic, and also the core team has increased the whole detection APIs. We have added those things, and we are able to improve the quality as well as performance. So the world related checks are free holes, holes mismatches, and holes pair mismatches were the three key functions available in the bolt nut check or the connection check. So we have improved this holes detection and database, as well as few bugs and were fixed. And with that, we were able to achieve very good efficiency for this release. Okay. Some of the default parameters for the bolt hole mismatch or bolt nut mismatch or bolt nut size mismatch were tuned to automotive use case so that it can identify all the true errors, okay, and reducing the false reports. By doing all this improvements for this release, we were able to reduce 30% of the false reports, and 30% of the false report we were able to reduce. By that, the user time initially around 1,000 plus slides were created for a connection check from MVD side for a typical car model consists of 10,000 parts, and user was spending additional time for this false reports. Now we are able to reduce the reports and their time as well as the overall time of the verification process. The next one is comparison. In the comparison, the widely used functions are CAD to FE comparison. In the CAD to FE comparison, if the mesh size, FE side, if the mesh size is very coarse, we need to use higher tolerance. If you use lower tolerance, then the match percentage will go down and you will never able to get 100% match, even though the mesh fits the joint. The FEM data on the CAD, on the edge fillets, on the corners or around the hole, somehow the caudal deviation will become big and you will lose the mapping of the nodes or the edge of the elements to the surface edge. So due to that, somehow you see the match percentage will not be 100 even though it is perfectly matching. So some of the customer were raising these issues. Even if they change the mesh size to coarse or fine, the match percentage should be 100 if the deviation of the FE from the CAD is very less. So we have come up with some idea of ignore minor mismatch options. So with this minor mismatch, if the CAD is matching with the FEM data and each and every node of FEM data lies on the CAD, and the distance between those nodes and FE is less than certain value, for example, 0.01 millimeter or 0.02 millimeter or 3 millimeter. If that is the case, and if the centroid of the both of parts and area of the both parts and match percentage of both parts are more than 95% above. Okay, in this case, we can judge these parts are 100% matching. So we have come up with this kind of a new parameter. So this is widely used in a meshing factory where they get the model from their meshing factory and they want to judge whether all the nodes and surface and all the nodes and elements are lying on the geometry. Okay, so for that kind of reason, this new parameter can be widely used. Okay, and user has to turn on this option. By default it is turned off, which is using the conventional method. And if you turn on this option or set this option to ignore minor mismatch, then this new round off value will be applicable, um, and you will get the report and the match percentage will be tuned accordingly. But 10 millimeter mesh is too difficult to control because it's too coarse and we are not able to get 100% for this. So there is a limitation still, but we are able to get 100% match for less than 5 millimeter mesh. Okay. And I have a recording for this. I will try to take one example of 5 millimeter mesh and run this through this new interface. Okay, so this is a new interface for running comparison. As soon as you click on the comparison ribbon, you will get this comparison. Then you can select the input data and your report folder and run the comparison. So this is the same workflow as the previous, the TK window. Um, and the configuration is also same. For now, I'm trying to run with 0.1 tolerance for a 5 mm mesh model. Okay. Initially, without that new option turned on, you should be able to see that match percentage is not 100%. So it shows 99%. And some of the elements are more than 0.02 millimeter. So customer says 0.02 millimeter is negligible. Usually point up to 0.1 millimeter, they allow for correcting warpage. So 0.02 millimeter is really very small and we can ignore them. So turning on this ignore minor changes, now we will rerun this whole comparison and you can see the results. So second time, I'm trying to run only check option without report generation. You can see quickly the results are populated in the browser. So in the browser, you can see 100% match. And now, if you load that result in HyperWorks, you can see that mismatch elements are shown here. Okay, but the match percentage will be 100. Just for reference, I'm keeping those mismatch elements in the model itself so that user can review it still. But if lying on the surface, but there are some elements which are more than 0.02 element, but which is less than the tolerance. Okay, the tolerance is 0.1 millimeter.
Yep.
So for now, what we have done is we have added the support for UID attribute, same as part browser, so that the compatible between part browser and MVD browser will happen without any troubles. So this UID, now we are leveraging it in BOM comparison, topology comparison, where you can apply filters based on UID. And we can also run batch measure directly from MVD side after comparison. And for unmatched parts, we can run batch measure, or we can read the result XML file from MVD and submit to part browser, and part browser from part browser you can keep batch measure as well. So back and forth, there is no problem here afterwards. Okay? So as you see, the UID can be used for filter. For now, we were supporting only the part ID based, part number based, and uh, yeah, part number based. Now we have added the UID base so that user can filter a part for comparison based on same UID left hand side and right hand side model with revision same or different. Okay, so this kind of new filter is added in addition to the BOM comparison. The next one is same location option. We have some filters in comparison for comparing the model on same location or symmetry translation or auto AI approach. The same location means two model lies on the same coordinates. Okay? At any cost, whether user select symmetry or translation at any cost, first we always try to compare the model at the same location. If it doesn't exist, then we go for a symmetry or translation. So we have kept this option and we turned it off. By mistake, some customer used to turn it off. So for now, uh, hid, uh, we have made this option available in the configuration byte, but we have deactivated or hidden this attribute from the configuration file. But at any cost, we are running it in the background. So apart from the same location, we do have symmetry for LH and RH comparison. We do also have a translation for transformed comparison. We also have an auto comparison where any direction, rotation, translation happen, we can compare at one shot. So internally, we are switching between AI and auto comparison for CAD to CAD. We are using auto, and for CAD to FE, FE to FE, we are internally switching to AI approach. Okay, and there is a AI approach of checkbox available here. If you turn on this option, we are trying to do a topology comparison and also AI comparison sequentially and compare the match percentage, whichever is best match. We are trying to fix that match percent and display in the report. In the report, you can clearly identify whether it's a result is from AI or the topology comparison. The reason why we do this is sometimes because of a geometrical complexity, for example, one long surface and one small whole mismatch. Will show the entire surface is mismatch and match percentage will be less than 10% or 15%. But if you submit the same model to AI approach, it will give you 98% match. So to avoid this kind of things, we are combining both and we are trying to get the best results if you turn on this option. Of course, little bit performance will come into picture, but the result will be much stable. And even with 1%, 2% difference, you can able to compare and report in the PPT or Excel report. So these options are already there. By default, I turned off all the options. Whenever this kind of comparison needs to be run, then these options can be turned on. So the next one is surface offset. Some of the customer in APAC regions have surface data, that is inner surface or outer surface of a part for a body in white. Okay, for those surface, they try to apply offset function to bring it to the mid plane. So they will have a reference line to show the direction of the offset. They will also have a thickness value to offset half of the thickness. Okay, so some of the customer recently wanted to compare the offset data with the original CAD data. So it's a CAD to CAD comparison, but solid CAD versus surface or outer surface versus mid surface. Okay, so this function we have added now so that user can execute offset. And by default, I turned off this option. I kept it as a default so that no comparison will be executed from the offset configuration. If user select check option, then after offset, comparison will execute and the results are the match percentage between the outer surface and mid surface will be shown in the comparison browser. Now user can choose check and report. So it will apply offset, then it will perform comparison, then reports will be generated and reports will be stored in the report folder. Okay, so this kind of a flexible option is added so that for entire body in white, you can run blindly comparison offset so that it can offset, it can perform comparison and give you the report so that you can understand wherever there are some deviation in the surface that needs to be fixed, or they can fix it in the FE side as well. Okay. And for running the comparison, we do take the default values from the comparison configuration and run it. I'll give you a small demo on this offset function. So the normal offset function, you can run it from the comparison or verification browser. So for now, I'm selecting CATIA files. I have a folder where there are two files, cat part files. In this cat part file, there are some lines which show the directions for the offset. From the line, we can also measure the thickness. Okay. Some of the CATIA users manage this kind of information. So we can measure the thickness, calculate the thickness and put it in the browser. From the thickness, we can do offset by divide by 2. Then we can store that as a HM file. Then we perform the comparison. Then we create reports. All these things happens in one shot now. In olden days, user used to do comparison. Then they used to bring the CAD software to visualize the or to cross-check the comparison result, I mean offset results. Now you can see the match percentage comparison happened and HM files got generated. Okay. So now we are going to turn on the report option so that we can see the reports. Sorry, the reports are already there. So the reports can be seen. Yes. So this is left-hand side model is the original surface, right-hand side model is the offset or mid-plane model. It got compared. So all the gray part shows it's matching, but it is 98%, 92%, 80, 88% matching. Okay. And there is the Excel report. You can see the model in 3D view as well. So now you have a comparison, you have offset, and you have a report together. Okay. So the next one is intersection check. We have added a symmetry filter. As you know, intersection check at the design or CA team usually happens on a full vehicle level or subsystem level. Usually first time when you get the new CAD data for the first phase of the CAD, you will have a lot of intersection. It typically of 10,000 parts will have almost like 1,000 plus slides or 1,000 places where it get intersected. And in this intersection, if you have LH and RH model and if you have issues on the LH side, Similarly, RH also will have a similar issue, usually in the new designs. So when we try to generate report, we used to write reports separately for the LH side and RH side as well. So this example show you this bumper side. Here it is intersecting. Similarly, here also it is intersecting. Same part, they are using it both as an instance. Okay. So now when we generate reports from MBD, we do generate reports on the left hand side separately and right hand separately. But now with this new options and symmetry filter is turned on, then we do avoid one report, then we write only one report. Inside this report, we turn on this flag and say that uh, this is happening on the both side. Okay. So this option can be turned on from the intersection check configuration where the symmetry collision is there, where you need to input the tolerance and overlap ratio and the symmetry plane. Okay. So this is the filter. By adding this, as I said, there are 1,000 slides get created at almost like 200 to 300 place, we can see this kind of repetitive because of the symmetry. So now we are able to avoid this kind of reports, and we are able to uh, reduce 30% of the report generation. So user has to entirely check all the 1,000 slides. Now they can check only the 700 or 800 slides. So the performance increase. We don't have to take that much time for report generation, and user time is reduced and performance has increased. So number of slides also increase, that reduces the memory and CPU time as well. So with this flag 0 and 1, we user designer can understand now that this problem is happening on the both the side, but the report is coming only one side. Okay? So the tolerance is nothing but when we are trying to do this collision check, if the left hand side and right hand side have intersections. So for example, in this case, 4 places on the left hand side is intersecting, and the right hand side also 4 places intersecting. So after running our original collision API, there's a new API created that will take this 4 collision and do a symmetry or mirror and find out this same location is matching within this tolerance. So the tolerance plays major role. For now, we keeping 0, and user can increase this tolerance to 2 or 5 or something. This is these recommended ones are 2 to 3 millimeter. Once this reflected locations are matching, if all the 4 locations are matching, we say an overlap is 100%. If only 3 places are matching, so it could be 70%. So for default, we are keeping 60%. The user can tune this value to filter these symmetry solutions. So not only automotive, electronic industries, heavy industries, all have the similar issues, and now they can filter this section. I don't think so. This is available in any other CAD software as well. So this is a custom sponsored project which we developed. Now finally we added in the core solution itself. So I'll give you a quick recording on this collision check as well. So in the verification browser, you can go to configuration and you can set all the default values. Then under intersection, symmetry collision, you can turn on this value. Now perform intersection by right-clicking on the verification browser. Select your input data. From now we are choosing JT assembly file and number of cores, resetting it to 2 and running the intersection. So this will run and it will produce only one report. With default option, it will produce 2 reports, but for now it will show only one report as you see here. As you see the report quality also from the beginning onwards, we are keeping a very good report quality so that in the center place the XDD report which shows with best view, and side by side it also shows 3 best view, other angles as well. Okay, so recently none of our customers have customized this report. They are using this out of box solution itself, because in olden days they used to communicate this in different languages because their designers are different country and they are using different languages. But now with the single report with 3D embedded, they are able to communicate with only single report, single PPT without writing or adding any more information. The only thing they are touching upon is this bottom area where they write more information and about getting answers and where is the data located or which is the server which has this CAD data and so on information.
The next one is regarding spot weld comparison. Spot weld comparison is getting more attraction recently because number of spot welds in a model typically is around 5,000 locations. Okay. But if you are considering the continuous welds, if you consider the continuous welds and spot welds put together, it will be like more than 10,000 1D elements. So usually they wanted to compare this model A versus model B, which has 1D elements. So this Spotwell comparison can compare this two model which has 1D elements, and it finds out differences in terms of locations, PID, and stack mismatches. Okay. So for this mismatches, they wanted to get the report, but they wanted to send the feedback to the designers as well, designer the CAD software itself. Okay. So they requested some of the function like after running the comparison between two spot welds or two 1D elements, they wanted to export a connector file which has all the matchable and unmatchable 1D information, okay, for both base and variant. So we added this options in this version so that by default we are doing this because we came to know that a lot of people are interested in the same function, so we made it as a OTB. So for the base model, it shows non-unique file and unique file. So the non-unique file which has mismatches from the base to variant, and the unique ones are common between base and variant. So that has no issues. I mean, it's 100% overlapping. Similarly for the variants. Okay. So as you run the spot comparison at the report folder or working folder, you'll get this kind of a VIP file. So VIP is HyperWorks supported connector file format, and it's a simpler format. The reason we choose VIP is which has the spot gun diameter. Recently, that is related to all the spot gun, all the spot well check and spot comparison related to spot gun check. So we are choosing the VIP information for now. The next one is while creating this report, 5,000 connectors overlaid together, and they wanted to differentiate the color between base and variant. Initially, we were having same color for both base and variant uh, connection informations. Now we are given options whether user can change the color between base and variant. This can be done through the configuration and the template as well. Okay. So I'll run a quick recording on this. Spot comparison can be accessed from verification browser. You need to input two set of data. For today, we can choose a very simple one. On the left-hand side, we can choose a FEM data, which is of Dyna format. On the right-hand side, we can choose a spot well file. It could be a connector file. Okay. So this spot well comparison can do a connector versus connector, a model versus model, or CAD versus model. All the three combinations are possible. So now we have chosen a Dyna and a Spotweld file here. And we can perform check option or check and report put together using both options. And number of course, I'm choosing 2 and running this function. So this will import your FEM data and convert it to BOM. Then it reads the Spotweld data. They compare that FEM data and Spotweld data. The FEM data has a 1D elements. Then it creates the reports wherever there are mismatches. Since it is a small and simple demo module, it has only extra elements, and it has 466 on the left hand side and right hand side 466 connectors. Out of that, on the left hand side, 3 mismatches, layer and positional mismatch. On the right hand side, you have large number of mismatches. For those mismatches, now we are able to write connector files like this, base and variant, unique and non-unique files, so that user can read this kind of information directly into their CAD system or in Hypermesh for proceeding connector modifications. And for changing the color, you can go to configuration reports and you can change the spot comparison base and variant color. So now I'm not running it, but you can use this option once. Then the next time onwards, you will get that color in the report. The next one is spot weld check. The previous one was spot weld comparison, but this one is spot weld check, which takes data as well as spot weld and tries to see if the realization can happen on the data without any problem. In this, one of the function is called missing weld. Okay. In spot weld check, we have 12 function. Out of that, one is called missing weld or few connections, where we are trying to detect missing spot weld on the flange. On the right top side image, you can see a red the spot weld representation shows, which says this area spot weld is missing, but this transparent places the spot weld exists. So this is the few connection or missing function in spot weld check. So now this was creating lots of false reports as well. Sometimes this spot wells were coming close to this fillet or this kind of a step or near to the hole. So the core team has helped us to tune all these things and created a new API. In addition, we also implemented some of the filters inside the function. With that, we are able to increase the performance and decrease the false reports. And we also added some logics. For example, if the missing wells are there, we also check its uh, closest spot wells and see if this component links and this component links are same. If it is same, we are trying to do some workaround. If it is not same, we are trying to do some workaround. Based on that, we are able to further reduce the false proposing connection missing wells. And for flange gap, for example, at the spot pool location, we try to measure the distance between two flanges. If the flange gap is not appropriate, then there are chances where the rupture might happen or rupture may not happen. So most of the automotive companies wanted to maintain this flange gap correctly. So as a default value, I set to zero point 0.1 millimeter, which was very strict, and most of the customers they were forgetting to turn on or tune this value, and they ended up in creating a huge number of slides. Now we have changed this value to 1 so that you can reduce the initial slides from hundreds to few. Okay. With all these improvements, we were able to reduce 50% of the spot weld reports in this new release. So out of that, the major contribution came from the missing wells, where we were able to improve our logics near the fillet steps and feature edges and holes. Usually, if a hole or bolt hole exists, we don't spot well nearby hole also with certain ranges, certain distance. So this distance can be input in the missing well parameter itself. So having all this logic, we were able to get a good result in this new release. And by default, we have changed this, and the user don't have to turn on or off any of the options in the parameter file. And this was a data given from our customer, and this was tested on a BAW model, which consists of 5,000 locations. The next one is comparison report enhancements. This was also long pending requirements from customer. On the MVT side, we used to write 16 results. In the past, we used to write 32 results in one slide. Then later on, we have added this assembly images, this assembly images, and we increased the size of this and made 16 results in one page. So now we have added additional options so that user can select 16 or 4 or 1 layout so that user can see this result in a bigger way. Even now, some of the customer prints this slide and take to the discussion with analyst or the modeling engineer. That's the reason I'm keeping this color of the slide, background color, and the color of the images very light so that they can print it and take it to the discussion. So now they wanted to make it bigger and print it and have a discussion so they can choose the layouts to 1 or 4 so that the picture will be bigger. For now, we are keeping this layout only 16:1. User cannot change this value to 3 or 2, or that's not possible for now. But in the future, yes, we are thinking to leverage our report director so that we can have flexible reports as well. So I'll give you one recording on this report layout. By default option, if you run the comparison, it will give you 16 results per slide. Now from the comparison slide layout, you can change this value to 4 and run a comparison. This is a one-time change and run a comparison. Then you will end up in getting 4 reports per page. Now the comparison is completed. Now we are visualizing the report. In the report, the first page remains same. It's a summary report. From the second page onwards, we can see that the layout is changed to 4. Okay. By changing the layout, we can also see the images are bigger. And below the image, there are some text which looks very small, but that can be always tuned from the template only once. Then the size will be proper. So second time I'm running with one result per slide. The comparison is completed. Now we are looking at the report. So this kind of reports can be achieved. Yeah, this was also many customers requested me, like electrical industry, heavy industries, and so on. So I was not really proposing any custom solution, and I was trying to see how many requests I get and what is the business cases. And now I'm able to deliver this in this current release. And along with the PPT, we are also able to manage the same number of results in Excel as well, so that from this link, you can drive the Excel report. From the Excel report, you can visualize more details or BOM view with additional of 3D images. The next one is the licensing system. Okay, so far MVD was running in batch mode, and in the past, MVD was drawing until 2017 version. MVD was drawing completely stack units. For example, if you are running 3 cores, we used to draw 3 into 21 hyperworks units. 63 units was drawing. Okay? After some time, so the units got a little bit changed. Now we are back. Now MVD will be stacked with this kind of rules. Uh, for single batch mode, we will still draw 21 hyperworks units. For 2 batch mode, okay, we will draw 42 hyperworks unit. Until 4 batch mode, we will draw 50, and until 8, we will draw 50 hyperworks units. Okay, so what it means, when we run comparison or any function in MVD, there is a core options. Okay, if you select this core 3, then you can check on this table. From 3 to 4, it will draw 50 hyperworks units. Okay, so this is changed for the whole hyperworks. MVD runs on hypermesh, so batch mode for hypermesh follows the same rule. Hypermesh, hyperview, hypergraph, and all the hyperworks desktop products will follow the same rule. This needs to be communicated to customer, and if we are taking a new HyperWorks release version to customer, and you need to inform them. So to get this licensing system to work, you need to have a new license manager 15.0 in addition to the new license file. By mistake, we are using old license manager. The license, the units calculation will go wrong. It might draw a huge number of license units, for example, 120 UN for 2 or 3 cores, which is written here. Okay. The next one is some of the bug fixes which we have covered in this release. For the legend, queue comparison is also getting very popular because it's quick, faster, and the results are shown directly on the graphics. There are some issues on the legend, so that is also fixed. There was some import issue on the step data that is also fixed. In the BOM comparison, partial match percentage was not correctly calculated. That is also fixed. In the queue comparison, other places were also, and also multi-variant comparison was not working in the past release because of regression, so that is also fixed. And some more bug fixes have been mentioned here. And at the last line, one known limitation we have, since we have changed all the GUI interface, one regression happened where if you try to copy paste your file path directly into the selection window, then the file path will not be respected first time. If you do it on the second time, it will work fine. So this limitation is coming from the framework side itself. We are working on it. Once we have fixed, we will improve it. Some of the frequently asked questions I've listed here. For the last 6 months, I received this kind of queries. So usually for CAD to CAD comparison, we show mismatches in 2 colors. What does that means? Okay, so blue color indicates the mismatches from the base, and red color indicates the mismatches from the variant. If you put both the colors same, you won't understand if the models are overlaid. So that's the reason we are trying to differentiate these colors. Okay, and of course, these colors can be tuned from the configuration report side. The another asked question is the direct property assignment is not working. By default, we are trying to read the thickness and properties, all these things from the HM comments. Okay, but user can override this to change it to property so that we read all the information from the property, direct property, and we try to create and map each and every thickness on the element itself. At the end, at the MVD side, we map all the properties or component thickness from component or property to the element itself and keep all the information on the element itself, so that if you have multiple properties or multiple thickness on a components, we try to support them so that in the comparison the result will be much um, precise. And the third one is no result found error repeatedly seen. This error comes when the comparison happens and match percentage is 0 for all of the parts. There could be so many reasons. Some of the reasons are mentioned in the below places. For example, model units are different. Okay, you will get this kind of error because left-hand side model might be millimeter, right-hand side model could be meter. And if you try to compare it, it will not compare and it will say the units are different and you will not get the results. And it will say no result found. Some of the customer reported me when the model coming through the WIS markup or Team Center, some version difference, the units are getting changed to meter. But if you are trying to use an assembly file versus assembly file comparison, we detect the units and we try to unify the units and we convert everything to millimeter and try to compare. But if you're not using assembly file, we won't have a way to convert all the units. Okay? So that's the reason you will see this error. So better to import that CAD data into Hypermesh and scale it and save it as HM file and give it to MVD. It will work. The next thing is models are in different coordinates, not able to compare. If two models are different coordinates, as a default, we are trying to do a same location comparison. But if you think the models are in different coordinates, you need to turn on symmetry, translation, or any of our auto options so that the comparison will happen even in the different coordinates. As I said, for default, because it's a widely used use case, I keep same location as the default. That's why you see this error. Sometimes you'll see scratch file exist error. That means when we try to run a comparison on MVD side, we try to scatter the CAD data or FE data and create a bound file. The scattered folder, we name it as a scratch folder, MVD underscore some numbers, and that is a scratch file. That scratch file exists. We cannot run one more check because that file will also be considered for the next run. So it's better to delete, and if you see this error, delete it and run it one more time as it is. And sometimes you might see a component name or a part name consists of underscore skin. Okay, it gets a special treatment and it tunes the match percentage and give you the results. That's because some of the automotive companies manages the outer skin mesh data, for example, engine or transmission assembly, where they try to more create mesh only on the outer skin, but excluding the inner area and so on. So like cylinder head, bulkhead, and so on. So for that, they name it as underscore skin. So MVD detects those names and do a scaling of a match percentage and give you the results. So that's why you can see the results might be a little bit different if you have underscore skin. So best thing is you can rename those components or parts and run it. But in the next release, I'm coming with an option to turn it on and off. For now, it's hard coded, but soon in the next release, I will have an option for this. And this was a major automotive company's request. Based on that, we have done some study and workaround to do this for skin parts. The next one is sometimes the MVD browser shows 0.01 millimeter thickness, what it is. When we're trying to import CAD or FEM data, we try to extract thickness from its metadata or its components or property or whatever. But if those informations are not there and it is really must, the thickness is a must for comparison, then we added a dummy thickness of 0.01 millimeter. So when you say 0.0, if you see 0.01 millimeter for FEM data, it means for that solver, due to some reason, the thickness extraction did not happen. So it's better to check the data and take a proper precautions. Okay. The next thing is ways. Is there any ways to speed up comparison? Yes, we have implemented quick comparison. That is a quick comparison, which is 2 or 3 times faster than default comparison. You need to turn on quick comparison option to get more speed. And you can keep it only for check so that it imports the model at once, checks it in the graphics and give you the results in graphic itself. You don't need to create reports. So that is one way. Even in the last version, we have added part selection on the graphic itself so that you can load the model by yourself, select the parts from the graphic and run the comparison and see the result on the graphic itself. So these are the ways to improve the speed. In addition to this, you can turn off some of the report options. For example, you can keep only the reports up to PPT file only or Excel report only. Or in the PPT file, you can restrict only the first page or only the second page, so on. So this kind of option will let you to increase the performance. The next one is group multiple slides. In the intersection reports, typically for a BAW, you will get around 400 to 500 slides. And each and every issues, you will have one single slide. So 400, 500 slides will be there. Now, some of the user wanted to group them in a single PPT file. So there is an option in the configuration file called group. You can search for group and the single and multiple option is there. And if you make it to multiple, then all the reports will be gathered in one single PPT file. The last but one, is it possible to split multiple solid to each part? Yes. On the CAD, for example, some of the CAD files, for example, CATIA product, if you import, some of the children CAD part file have multiple solids inside. Some of them are only single solids. Okay? So we have an option to scatter those multiple solid inside a CAD and create a separate part. So that's available in MVD. There is an assembly split option in the CAD configuration CAD. If we turn on those option, then multiple solids inside each part will be separated and it will carry the same part name, part number, materials, and thickness of the original part. Then Q comparison sometimes doesn't give you results. Q comparison, the only important thing is thickness should be available on the FEMD. That's the reason we have added dummy thickness. So if you don't see thickness, it will not work. So thickness is must for the Q comparison. So these are the some of the FAQ. With this, I'd like to end up my session. Thank you so much.